All right, we got notes. Binomial theorem. I thought this was up next. Actually, logs was up next. We'll do logs next week, I guess. Logs, I think, will be more than one day. This should just be one day. All right. A binomial is a mathematical expression consisting of two terms connected with a plus or a minus. This is pretty simple, right? I mean, it could be anything. Normally we see something like 2x plus 5. If you want to be maybe a little bit more specific, they should probably be two unlike terms. Otherwise, you could just combine them together into one. But we kind of understand if there's two different terms, then yeah, they're probably unlike each other. So normally they're stuck, they're separate, you cannot combine them. And we work a lot with binomials. A lot of factoring creates binomials. A lot of like rational expressions is factoring, and then you get binomials and you cross them out. And moving on from there, here is this is my favorite math joke ever, guys. This is it right here. 230 minus 220 times 1/2. If you solve it carefully, you'll find the answer is 5. What do you guys think about my math joke? There's a little bit of a spoiler on the rest of the sheet. Obviously you can see it's still here. If you actually solve this correctly, what should the answer really be? 220 cut in half, which makes 110. And what is 230 minus 110? 120. This should be the answer. If you aren't very good at math and you solve it and you don't know about PEMDAS and you do it wrong, you do 230 minus 220, which is 10. And then you cut it in half, you get 5. Now, if you do it correctly, the answer is 120. And it says if you solve carefully, you'll find the answer is 5. And this is a great joke because it will trigger people who think, oh, I'm actually okay at math. I actually did a pretty good job. If you guys have seen those cringe memes on Facebook where it asks you to solve and discuss in the comments below what you think the answer is. This is one that's great because people will be really upset and really great. No, you're doing PEMDAS wrong. But what makes this such a great joke, as we heard, is that it's really a factorial joke, okay? In math, this exclamation mark actually changes the number. And so the joke is that 5 factorial is 120. So, it's a great joke. You guys can laugh now. It's weird. No. Thanks, you guys. Thanks. It is a great joke. So here we are. A factorial is a mathematical expression expressed with an exclamation point calculated by the blank of all previous blank numbers, right? This is the product, which means multiply, of all the previous natural numbers. That means we're not doing fractions, and it's not whole numbers, which would include 0, because otherwise we would be multiplying by 0, and the answer would be 0. So we're multiplying by all of the smaller natural numbers. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. And like we said before, 5 times 4 times 3 times 2 times 1 is equal to 120. The thing about factorials is that they get big really fast, and they're also really repetitive, because 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, and it's just 720 times 7, or just 7, which is 4,000 years. Not a big deal. Now, 0 factorial. Anybody know what 0 factorial is? 1. Honestly, It doesn't make a whole lot of sense. It's kind of supposed to hurt your brain a little bit. And there's proofs of it and there's reasoning behind it. You know what? The best path forward is just nod your head and just say, okay, 0 factorial is 1. In the calculator, because we're definitely going to want to use a calculator for these because nobody wants to do 10 factorial in their head or on their paper. In the calculator, you need to know how to find the factorial. And so here's 2 different ways to get there. You can either press the math button over 4, or you can do a fancy way. Second, 0, 3, enter. It's a fancy way to go through the catalog and get it. Either way, they both work fine. Honestly, the first one's probably better, the math over 4, because that just gets you where the rest of those probability things are. Any issues? Was everybody able to find the exclamation mark, the factorial button in the calculator? All right, now let's solve both this exact question 2 ways, once by hand and once by calculator. Well, let's do the calculator first, surely, because that'd be easier. I'm gonna use alpha y equals to make a fraction. I'm gonna put a 10 on the top. Math over 4. On the bottom, 3, math over 4. 8, math over 4. And when I get all of this put in, I'm maybe expecting a crazy number, and actually, it's 15. Now I thought that factorials were supposed to make these crazy numbers and these crazy huge numbers. Have a great weekend, Sydney. So how do we get just 15 here? Factorial math is really kind of like grown-up math, okay? Factorial math is something that flies over the head of high schoolers normally. Of course, we're IB high schoolers, so we're at that next level. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. And 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And like we said up there, factorial math is very repetitive. And so when you divide factorials, huge sections are going to be repetitive and huge sections are going to cross out. And so here is 8 factorial and here is 8 factorial built in to the 10 factorial. And all of those numbers, which is going to total like, I don't know, 10,000 or 40,000 or something, it's just going to cancel out. And they're just all going to go away. And so what we really have is 90 divided by 6, which is how we get 15. Now, is it super popular for them to ask you to do math like this by hand? It depends. When I was in college, I did a little bit of training for these like really, really hard math tests. Only a little bit of training. There are these math tests called like the Putnam, which is a math test for only math majors, for only the smartest math majors. Out of 100, the average score is normally a 0, which is pretty funny. Over half the people normally get a 0 on this exam. But anyways, I only took it once and I got a 0, and I'm not that ashamed of it. I'm okay being at pretty average when it comes to that. But this kind of math, like you can use as a way to work on really complicated factorial questions. It's just kind of a neat way to understand factorials that they're very repetitive. When you stack them up, it's repetitive. That's all you need to know. Up next, let's talk combinations. The number of ways you can choose a subset of a group where order does it matter? You guys have done combinations before, right? Normally you learn about combinations and permutations and the difference between the two. And we're pretty much just doing combinations in IB this week. So we're not gonna worry about permutations at all. Permutations is where the order does matter, but for us, order does not matter today. So if you've got 5 letters and you need to choose 2, A, B, C, D, E, well, you could do A with B, and A with C, and A with D, and A with E, and you could also do B, we already did A, with C, and B with D, and B with E, and we already did, okay, now C with D, and C with E, and D with E. Ugh, just working one at a time, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different ways to choose 2 letters if you have 10. Again, we definitely don't want to be doing this by hand if we don't have to. And so, written as NCR, where N is equal to the total items and R is equal to the chosen items. I mean, there's a couple different words you could say in there, but I think those are good enough. And so we could have 5 choose 2 if it's a 5, C, and then a 2. And this is in the calculator as well. You can go to math, over. And this time, instead of pressing 4, you can see NCR is button number 3. You put the 5, and then you put the 2, and it tells you 10. Now we already figured out it was 10, but nice, it's 10. Now, there is a formula here, written as NCR. Now also, we have it written like this. Now we just did vectors. Just kind of the way it worked. We were doing vectors 2 weeks ago. Sometimes you do these far apart, depending on which order you do. But the way our order worked, I know that we just did vectors. And these do look like vectors, but they're never stated as like, you know, R with the arrow on it equals. So it does look a lot like vectors. That's just the reality of it. And we have a little formula here. The formula is N power, or N factorial, over N factorial, N minus R factorial. Now that looks really crazy, but actually this is a super quick and easy formula to use. If we were doing this formula of 5 sub 2 or 5 choose 2, it would be 5 factorial over, oh, I think I got the formula wrong. Oops, it's R. Otherwise the ends would just cancel out. Come on, what are we doing? 2 factorial, 5 minus 2 factorial. All right, willing to admit to a mistake, we caught it. We got it done. Formula's right, trying to be a cool guy and not look at the notes for the formula. Fair enough. Now what that does is that this in here will simplify to 5 factorial, 2 factorial, 3 factorial, because 5 minus 2 is 3. And the way this works is 5 goes on top, 2 goes on bottom, and then whatever the difference is, whatever's left, whatever else you need to get from 2 to 5, which is 3, is what goes on the bottom. Of course, you could type this whole thing into the calculator, but it's literally the NCR thing. So there's no reason to ever do this formula in the calculator because NCR is the button that does this for you. The only reason you would ever want to do this is if you had a no calculator question specifically that was asking you about this, or if you had an IB question that was messing with your variables a little bit and having you solve for different questions. So looking at this, this could be 16 factorial, 12 factorial, and then whatever the difference is, whatever's left, which is 4 factorial. Now, again, the way that this works is that factorials are super repetitive, and so this 12 factorial on the bottom is gonna get rid of everything after 12 of the 16. So let me elaborate on that because it's hard to just talk about. 16 times 15 times 14 times 13 times 12 factorial. And we're just gonna leave it like that. It's the 16 and then the 15 and then the 14 and the 13, and then we're just gonna package all 12 of those together. And then on the bottom, we have 4 factorial and 12 factorial. And those will cancel out and go away. And this is how all of this gets calculated. This is how the formula works. Again, not really often you're gonna be doing this by hand. And if you have a calculator, not really often you're gonna be doing this by calculator either, because just do the NCR and you'll be all right. I guess let's go ahead and figure it out. This would be 4 times 15 times 14 times 13. The answer would be, ooh, still a very big number. Oh, this would be, that is 2 times 3 times 14 times 13. All right, I got a number just over 1,000, is that right? Try to take a shortcut.
About 1820.
Oh. Totally right. 1820. Good catch. Maybe 2 goose. All right, going on. At this point, we've set the groundwork, but we haven't really done all that much. We've talked about binomials and what those mean. Okay. We talked about factorials. Okay. We talked about choosing, using combinations, but okay, we've already known that. So here comes binomial expansion. This is when you have a binomial that is squared or cubed or to the 4th power. And let's do a little bit of math here. Actually squaring these things, that would mean that we have a plus b times a plus b. And if we FOIL that, it would be a squared plus ab plus ab plus b squared. And these two things should combine together and we'll have a squared plus 2ab plus b squared. Well, if we wanted to cube it, that would be like a plus b squared times a plus b. And we could borrow this one that we just got. So it would be a squared plus 2ab plus b squared times a plus b.
That's what you want to pass.
Yeah, probably. She needs to email me, that's my email. Sorry about that. Well, yeah, I don't want to do this binomial expansion. I don't want to have to multiply all this stuff out. And that is kind of the point, right? How can we find a shortcut? Let's look at a pattern. Here's what we have for this 4th one. I've got it all written out for you. You can notice it goes a power 4, and then the a exponents will count down. So it's a power 4, the next term is a power 3, a power 2, a power 1, and then a power 0, where it basically has disappeared. And the b exponents backwards are counting up, or they're counting down from reverse, however you want to think about it, right? 0 b's, 1, 2, 3, 4. And so there should always be 4 total variables in the power 4 expansion. 4 a's, 3 a's and 1 b, that makes 4, 2 and 2, that makes 4, 1 and 3, that makes 4, and 4 b's, that makes 4. That's just the pattern that we're starting to recognize, so let's see if we can find some more patterns. I'm gonna go down here and do maybe a plus b power 5. and see if we can use this pattern to come up with how it should work, okay? This fifth power should be a power 5, and then the a's should count down. A 4, leave some room for the b. Say b and write b. A power 3, leave some room. A power 2, leave some room. A power 1, leave some room. A power 0. Coming back this way, b power 1 or 0, and then 1, and then 2, and then 3, and then 4, and then 5. But what about those exponents? Okay, what about the 4, the 6, the 4? Where are those numbers coming from? And you may have seen this before, Pascal's triangles, everybody's favorite. Introduce Pascal's triangle here. This is kind of the fun way to do it, the informal way to do it. Pascal's triangle, have we seen this before? I'm sure, at least a little bit. You start and you add them up, and so the 2 is the sum of this little triangle here. 1 plus 1 makes 2, and that's a little sum. 1 plus 2 makes 3, and 4 plus 6 makes 10. And so it's very easy to create, and it's kind of therapeutic. And these coefficients from Pascal's triangle can also work as your coefficients. If we look back up here, a power 4 was 1, 4, 6, 4, 1, and the fourth row, really it's kind of like the fifth row, is 1, 4, 6, 4, 1. And so I know we're missing the coefficients for our random one that we made up here, but we can use the Pascal's triangle to pick up 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. And there we go. We did our expansion to the 5th degree of a binomial. Well, what is the general term for a plus b power 7? Ugh. So far, if we know that this is a plus b power 5, then we can get 6, 1, 6, 15, 20, 15, 6, 1. And if we wanted 7, that would be 1, 7, add these two together, 21. Add these two together, 35. Add these two together, 35. These two make 21. These two make 7, and then 1. Again, God, this is getting awful. Even using all these shortcuts and tricks, it's still taking forever. We've got a power 7 with 0 b's. A power 6 and 1 b. A power 5 and 2 b's. A power 4 and 3 b's. A power 3 and 4 b's. A power 2 and 5 b's. A power 1, 6 b's, and b power 7. Again, if you're looking at the board, it looks probably like a total nonsense, waste of mess, number, gross clump. But it's coming up with just following these patterns, different patterns for the variables, different patterns for the coefficients. Well, that's kind of the fun way to come up with our coefficients, but the fancy way is to use combinations, okay? Going back to our 5th power, the expansion of the 5th power uses 5, 10, 10, 5, and those numbers are coming from combinations. It looks like there is a small typo here. That should be a 4 that goes underneath there. And we can use our calculator just really quick to go into the calculator, go to probability, do some NCRs, and we can do 5 choose 0 makes 1. Now that's a little bit of a waste of time, so I haven't even left it on there. We can do 5 choose 1 and verify that it's 5. We can do 5 choose 2 and verify that it's 10. Okay, so we have this NCR and that can help us out. The advantage of using this is that the Pascal's triangle is recursive, meaning if you want line 10, you've got to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you get to 10. There's no way to skip straight to 10 for Pascal's unless you're some kind of genius who can kind of work it out in their head. This, you can skip right ahead to row 10 and not have any problem with it. Instead of Pascal's triangle, we can use combinations to find the coefficients. Let's look at how this is kind of working here. If we want the second term, then we need to use 5, choose 1. So the nth term is maybe it's better if we choose R because they like to use R here. The rth term is n of R minus 1. Right, the third term here is n choose 2. Okay, we're on to the last page of the notes. Actually, there's 2 example questions I forgot. Let's look at some of this. Binomial expansion, there it is. There's the formula. It's all the same stuff that we've been working towards. There's no big reveal here. It's A's and B's. The A's count down, the B's count up. You use your combinations to choose the coefficients in front. And so let's do this first example. Now, it's very easy when everything is A's and B's, but it's almost too easy. And so these questions will include actual things like coefficients and variables. So in order to expand this, we would have 3 choose 0. That's gonna help us find the coefficient. Then we would have 2x to the power of 3 and 3 to the power of 0. Now the first time you see that, it looks a little crazy, but it's the same thing, right? It's just that you have 3 A's and 0 B's. I know, it's a whole bunch of stuff, but again, in reality, this one power 0, it's just 1, it's just gonna go away, and 3 choose 0 is just 1, it's just gonna kind of go away. And so for this very first term, we have 8x cubed. Our next term is gonna be 3 choose 1 with 2 of the A's and 1 of the B's. Again, it's the same pattern we've been doing all day. It just looks a little bit harder because we have those numbers and letters introduced. It's kind of like we're taking this and we're losing one of the 2 x's, putting it down to 4x squared. And then we're gonna be multiplying by 3 because of the 3. And then we also have 3 choose 1, and we can use our calculator, math over 3, and then 3 choose 1. It's gonna be 3. If you got 3 things and you're picking 1 at a time, you can pick A or B or C. Anyways, we're gonna have 3, 4, 3, 9, 36x squared. That's coming from the 3 times the 3 times the 2 squared, which is 36, and the x squared is there. Up next is gonna be 3 choose 2 of 2x, and then 3 squared. Three choose 2 is also 3 times 3 times 3 times 2. This is gonna be 54x. And lastly, how many different ways can you choose 3 choose 3, 2x power 0, and 3 power 3? 3 choose 3 times 3 times 3 times 3. And I got 27. First time doing this expansion, how are we feeling? Not too bad. Using the formula, again, it's a little repetitive, but it's not too bad. Now, quickly, obviously I haven't left much room for this version, which has the negative on there. Well, all that negative does is maybe affect our sign. And I say maybe because remember, it's not gonna change all of our signs. Anytime that term is squared or to the 4th power, it's gonna stay positive. So what I'm looking for is here, it's gonna turn into a -3, but I have 0 of them. So it is still gonna stay as positive 8x cubed. Up next, I have -3 and only one of them. And that one -3 is gonna make me negative. Now the numbers aren't gonna change at all, it's just gonna change my sign. When I get to the next term, I'm gonna have -3, but I'm gonna have 2 of them. And 2 negatives are gonna cancel out and they're gonna stay positive. So this is gonna be plus 54x. And lastly, if I have 3 -3s, it's gonna stay negative. And so when you do this expansion and you have a negative term, it's not gonna affect every single one. It's only gonna affect it when it actually stays negative. So a lot of the time, if you have a very simple one like this, it's gonna end up every other time working out. Now that is a full expansion and it is a decent amount of work, even if we're just doing the 3rd, like the cubed expansion. And so a lot of times they'll ask you to find one specific term. So what they've asked us to find is the term with x4, x power 4, in the expansion of x cubed plus 2x, or x cubed, 3x plus 2, power 5. So we're looking for just one term, okay? We're gonna have 3x, and we're gonna have 2, and we need to figure out how many of each do we want. Now remember, it has to add up to 5. We can choose 5, 0, we can choose 4, 1, 3, 2, 2, 3, 1, 4, or 0, 5. So how many do we want to put in the A position, and how many do we want to put in the B position if A plus B has to equal to 5? What do we think? Grady helped me out earlier. Somebody besides Grady. You got it, Raina? What do you got?
You could like,
We want x power 4. So how many of these x's do we need? And what does that mean B has to be? 1, right? So we got 4 of those and 1 of those, and that's gonna help us zone in on the one term that we need, and we can do this, and 3 to the power 4 is 81, and x to the power 4 is x to the power 4, and 2 to the power 1 is just 2, and we can multiply this and get 162 x power 4. But this is wrong for the time being. What have we messed up? The coefficient, right? We have successfully taken our 2 pieces and the right amount of both, but there's always that coefficient that comes standard. And so we gotta figure out what coefficient should be going here, because 162 is only part of what we need. Remember, there's an NR, there's a combination that we need to choose. Well, the top one is gonna be 5. What are we gonna choose for the bottom? We've got one option of going with 2, you said, right? Let's think about it if we do it this way, okay? A5B0, A4B1, A3B2. This is the expansion, and I'm coming up short, right? And the first one that we have here is always 5 choose 0, because it's supposed to be R minus 1. The first term in that sequence, and you gotta go 1 short of that. So this would be 5 choose 0. Where we are is here in this position, the second position. So we need 5 choose 1, not 5 choose 2. Does that make sense?
I mean, like the second term.
Okay, excellent. So the second term, which is 5 choose 2 minus 1, which is like 5 choose 1. And if you've got 5 things and you're choosing one of them, you've got 5 again. So this should be times 5. And this is easy to do in our head because 5 times 2 makes 10. 810 x power 4. Okay. Not too bad, but just a little funky. We're using all of these patterns and keeping track of all of them in our head at the same time. Let's check out this question. Because I'm sure we expect IB to torment us somehow. We've got the expansion of 2x plus 1 over x to the power of 6. And we're looking for 2 different coefficients. So let's start with A. The coefficient of the term with x squared. Now, here's how you want to start it off. You got these 3 parentheses, okay? The first one is the one that looks like a vector. This is the one where you're using combinations. The next one is your A, and the next one is your B. And then you want to start by thinking about your exponents. You know they have to add up to make 6. It's either 6 and 0, 5 and 1. You guys have heard me do that a few times. Our goal is to come up with the x squared term. Now normally, if it's not IB, we're thinking, cool, x squared, we want 2 of them. But the problem for this question is that when we have 4 of this, that's gonna end us up with x squared on the top and x4 on the bottom, and they're gonna be canceling out in the way we don't want. So that's actually not gonna work for us. We have to think a little bit harder than that. This is an x, and this is canceling out an x. So if we make it 3 and 3, we're gonna have no x's left. We need twice as many x's as we have cancel out my x's. That way we can have 2 left over. So what is the choice for A and B? 4, 2. And it's not that hard. 4 and 2. Okay, if it is 4 and 2, what term is that? There's the 6, 0 term, there's the 5, 1 term, and then there's the 4, 2 term. Third term that we have.
Wait, it's 2, isn't it? Because you have the 0. Oh, yeah.
It's gonna be 2 because it's 3 minus 1. It's the third term. I was trying to then write it the way Devin. We're just, we got it. And lastly, let's make sure that we know this question is asking us only for the coefficient, which means we only care about the numbers. Obviously the x squared is the x squared. They don't care too much about that. And so I'm looking for 6 choose 2, 3 minus 1, times 2 power 4, because I have 2 power 4 from right there. And the coefficient coming from this piece is just a 1, and 1 squared, who really squares. Did anybody get the coefficient of this term? It's a 3-digit number. Ends in a 0. What do you got, Luke or Jack? What do we got? You type this in? So don't type in the X's because the X's are gonna mess you up. The calculator doesn't take the X's very well. We're typing in only the numbers that are not the X's. 6 choose 2 times 2 power 4. Yeah, 240. Nice job. B, last thing, and we are done for the day, for the week. The coefficient of the constant term. Again, I'm setting it up. 6, 2x, 1 over x. We want to think about, first of all, balancing term A and B, so they give us what we want, which is a constant term. So what are we going to choose for A and B as those two little things? 3 and 3. I accidentally spoiled this a little bit. But yeah, 3 and 3. That way they're going to balance out. That x squared and that 1 over x, there's going to be 3 of them and 3 of them. All the x's are gone. And that means over here, what are we going to choose in this position? So one way that you can kind of keep track of this is that the 2 that we ended up here is matching up with that B number of 2. Let's see if that works again. We have the 6, 0, the 5, 1, the 4, 2. We have the 3, 3. That means this is the 4th term, and we need 4 minus 1. And again, it's matching up with us over there. So if you're really confused about the choose number at the bottom here, it is the B term. We're gonna type this in, only the numbers, because we don't care, we only care about the coefficient, and also the letters are going away anyways. 2 power 3, and anybody got the number to end the notes, end our suffering? Yeah, 160. All right, these questions, there's not very much variety to them, right? They can ask you for the full expansion, or they can ask you for one particular thing, but that's pretty much it. I went ahead and just copied the homework onto the back of the notes. You can see it's only one page, it's only one IB question. Of course, it's like 10 marks or something, but that's it for the week.